Hello, my name is Leah, and today I will walk you through the On-premise WebLogic server to Oracle Container Engine for Kubernetes workshop. First, let's log into the Oracle Cloud account. From any browser, go to oracle.com to access the Oracle Cloud. Click the icon in the upper right corner, click Sign in to Cloud. Enter your cloud account name in the input field and click Next. If you have a free tier account provisioned, this can be found in your welcome email. Enter your username and password in the input fields. Note, you are likely to be prompted to change the temporary password in the welcome email. In that case, enter a new password in the password field. Click Sign In to open the OCI console. Compartments are used to isolate resources within your OCI tenant. Role-based access policies can be applied to manage access to compute instances and other resources within a compartment. Click the hamburger icon in the upper left corner to open the navigation menu. Under the Identity section of the menu, click Compartments. If you don't already have a demo compartment, click Create Compartment. In the name field, enter Demo. Enter a description of your choice. In the Parent Compartment field, ensure that your root compartment is selected. It will have the same name as your Oracle Cloud account. Click Create Compartment. In the list on the left-hand side, click Policies. A service policy allows OKE to create resources in your tenancy, such as compute. An OKE resource policy or policies let you specify which groups in your tenancies can perform certain tasks with the OKE API. Optionally, you can create more resource policies if you want to control which groups can have access to different parts of the OKE service. In the left side menu, select a root compartment for your account. A list of policies in the compartment you're viewing is displayed. Click Create Policy. Enter the following: a unique name for the policy. The name must be unique across all policies in your tenancy. You cannot change this later. A user-friendly description. Select Keep Policy Current. It ensures that the policy stays current with any future changes to the service's definitions of verbs and resources. A policy statement. It must be allow service OKE to manage all resources in tenancy. Don't apply any tags. Click Create. Click on the hamburger menu. Under Developer Services, select Kubernetes Clusters. On the cluster list page, select the root compartment and click Create Cluster. Select Quick Create. The Quick Create feature uses the default settings to create a quick cluster, with new network resources as required. This approach is the fastest way to create a new cluster. Click Launch Workflow. Specify the following configuration details on the cluster creation page. The name of the cluster. Leave the default value. The name of the compartment. Leave the default value. The version of Kubernetes. Select 15.7 or lower. Don't select version 16, even if it is the default version. Please select version 15 in such cases. For visibility type, select Public. The shape determines the number of CPUs and the amount of memory allocated to each node. The list shows only those shapes available in your tenancy that are supported by OKE. Select the available VM Standard 2.1. Leave the default value 3 for the number of nodes. Click Next to review the details you entered for the new cluster. On the review page, click Create Cluster to create the new network resources and the new cluster. You will see the network resources being created for you. Here you can see the cluster you just provisioned. When it has been created, the new cluster will have a status of active. Click the Cloud Shell icon in the console header on the top right of the browser. Wait a few seconds for the Cloud Shell to appear. Oracle Cloud Infrastructure Cloud Shell is a web browser-based terminal, accessible from the Oracle Cloud Console. Your Cloud Shell comes with the OCI CLI pre-authenticated, so there's no setup to do before you start using it. To complete the kubectl configuration, click Access Kube Config on your cluster detail page. A dialog appears which contains the customized OCI command that you need to execute to create a Kubernetes configuration file. Select the copy link to copy the command and then paste it into the terminal. To check that the kubectl is working, try using the get node command. If you see the node's information, then the configuration was successful. In order to have permission to access the Kubernetes cluster, you need to authorize your OCI account as a cluster admin on the OCI container engine for Kubernetes cluster. This will require your user OCID. In the upper right corner, select User Profile and select your username. On the Details page, you will find the user OCID, select Copy. Then execute the role binding command using your OCID. Now your OCI OKE environment is ready to deploy to your WebLogic domain. Now, let's clone the operator Git repository to the OCI Cloud Shell. Next, let's create the operator's namespace. We will also create the service account. And finally, add a stable repository to Helm, which will be needed later for the third-party services. Now, we are going to install the operator using Helm. First, let's make sure that we're in the operator's local Git repository folder. Use the Helm install command to install the operator Helm chart. As part of this, you must specify a release name for their operator. Next, let's check the operator pod. Let's also check on the operator Helm chart. Here we can see that the WebLogic server Kubernetes operator has been installed. So far on our journey, we have created OKE on OCI. We have installed and configured the WebLogic Kubernetes operator, and now we need to install and configure the traffic. First, let's create a namespace for the traffic and get its load balancer IP/hostname. We can also print just the public IP address. We'll need this in the next couple steps. Let's verify the Helm charts. You can also access the traffic dashboard by using curl by copying and pasting in the IP address you just printed. Now it's time to deploy a WebLogic domain and OKE using WebLogic Kubernetes operator. First, let's create the domain namespace. Next, create a Kubernetes secret containing the administration server boot credentials. Now we need to update the load balancer and operator configuration to specify where the domain will be deployed. Here we are going to use Helm upgrade to update the operator and traffic. To deploy WebLogic domain, you need to create a domain resource definition, which contains the necessary parameters for the operator to start the WebLogic domain properly. Please make sure to copy the provided domain.yaml file. Make sure to review it in your favorite editor or browser. Create the domain custom resource object. Next, check the introspector job. Check the pods in the domain namespace, and soon you'll see the server starting. You should see 3 running pods. If you don't see all the running pods, wait and check periodically. The entire domain deployment may take up to 2 to 3 minutes depending on compute shapes. In order to access any application or administration console deployed on WebLogic, you have to configure a traffic ingress. Execute the ingress resource definition. Once the ingress has been created, you can construct the URL of the administration console. If you didn't note down the external IP address, execute the print command to retrieve it. Construct the URL by using the external IP address followed by the word console. Then paste this into your web browser. Enter the administrative user credentials and click Login. You can click on Deployments on the left and see your sample web application. You can also test the sample web application by altering the URL. Thank you for joining me in today's workshop. I hope you found it helpful.